Welcome to ASU's University Academic Success Programs. This video will cover the topic, Chemical Elements and the Periodic Table. The periodic table organizes the chemical elements in a way that allows us to see trends and identifying characteristics of the elements.
How do we read the elements in the periodic table?
Depending on the detail included in the periodic table we're looking at, we may see more or less information about each individual element. Oftentimes, we'll see the chemical symbol, atomic number, and atomic mass listed for each element. For example, let's take a look at carbon. The letter is the element's chemical symbol. Carbon's chemical symbol is the letter C, and every element has a short abbreviation that allows for quicker notation. Sometimes, the element's common name is also included. The number on top is the element's atomic number. The atomic number is the number of protons in the nucleus of a single atom of the element. The number of protons in an element is the main identifying component that defines that element. In a neutral atom, the number of electrons associated with it is also equal to the number of protons. Next, the number on the bottom is the element's atomic mass. The atomic mass listed in the periodic table is the average mass of all of the element's isotopes.
What is an isotope?
Isotopes of an element contain the same number of protons, but a differing number of neutrons. So although the atomic number identifies a specific element, there could be numerous isotopes containing various numbers of neutrons associated with the nuclei. For example, 3 isotopes of carbon are carbon-12, carbon-13, and carbon-14. The numbers correspond to the mass number of each isotope. The mass number is the sum of the number of protons and neutrons in a given isotope. Since every carbon atom has 6 protons, we can subtract 6 from the mass numbers to find the number of neutrons in each isotope. So carbon-12 has 6 neutrons, carbon-13 has 7 neutrons, and carbon-14 has 8 neutrons. The average atomic mass listed in the periodic table for carbon is 12.011, which tells us the most common isotope of carbon is carbon-12, because 12.011 is much closer to 12 than to 13 or 14. Depending on the periodic table you look at, more or less information will be included for each element. In the periodic table we're looking at, only the chemical symbol and the atomic number are included. We notice that reading from left to right, the atomic number of the elements increase by 1 each time. By doing this, elements are categorized into groups and periods that reveal certain chemical property trends.
What are groups and periods?
The groups on the periodic table are the vertical columns of elements, and the periods are the horizontal rows. As we move from left to right across a period, the atomic radius typically decreases, meaning the size of the atoms gets smaller. This is because as the number of protons and electrons increases across a period, the electron is pulled closer to the nucleus. Due to this increasing pull of electrons toward the nucleus, electronegativity increases across a period. Similarly, ionization energy increases across a period because if an electron is pulled more closely to the nucleus, more energy is required to remove it.
Okay, so if those are the trends based on the periods, what do the groups tell us?
The groups are also known as families and tend to have more significant trends than periods. Grouped elements tend to have shared chemistry and also exhibit similar trends and properties related to increasing atomic number. Moving from the top down, the atomic radius of elements increase. Because the energy levels fill as we move down a group, valence electrons are farther from the nucleus. This results in a top-to-bottom decrease in ionization energy because electrons are less tightly bound as they are farther from the nucleus. This also results in a top-to-bottom decrease in electronegativity because the valence electrons are increasingly distant from the nucleus. The organization of the periodic table also groups elements into metals, metalloids, and nonmetals. Elements within these categories often share both physical and chemical properties. Metals are typically shiny, solid, and have the ability to conduct electricity. They can participate in ionic bonding with nonmetals and form alloys with other metals. Most nonmetals are gases and cannot conduct electricity. They participate in ionic bonding with metals and covalent bonding with other nonmetals. The metalloids form a staircase between the metals and nonmetals on the periodic table. The metalloids are unique because they can act as semiconductors and have mixed properties.
Okay, so the organizational scheme of the periodic table allows us to see patterns and trends between chemical elements. The elements are ordered by their atomic numbers, and this ordering provides an understanding of how many elements will interact with each other based on their chemical properties.
That's exactly right. The periodic table gives us a fundamental understanding of the elements that will be important for more advanced topics.